Hello, welcome to Lucy. Not I Love Lucy, not the science fiction film starring Scarlett Johansson, and not even the Beatles' psychedelic song from Sgt. Pepper. I'm talking about NASA's Lucy mission, the first NASA mission to study the Trojan asteroids near Jupiter and take a significant deep dive into the origins of our solar system. It is theorized that the Trojan asteroids contain primordial material that formed our outer planets, and Lucy will focus on 8 specific asteroids to learn all that they can about the past. Just like Lucy, the oldest known human remains discovered on Earth helps us understand our own human origin story. NASA's Lucy mission will tell us tons more about the early days of our neighboring planets, which kind of makes us planetary paleontologists.
Sweet!
I might just have to rethink Ridley Scott's Prometheus theory, right?
Welcome to NASA Edge.
An inside and outside look at all things NASA.
We're in Hangar AE on the Cape Canaveral Space Force Station.
Yes, and today we're going to be looking at the Lucy Rollout as it moves on top of an Atlas V from the Vehicle Integration Facility out to the pad. We're going to see some spectacular images, and we're going to see Franklin and Mick Waltman, our friend, out there at the pad to witness it in person. Should be a great, very special moment on the show, Chris.
I tell you what, Blair, I'm really excited about this mission because this is the first NASA mission that will be visiting multiple asteroids. We have 7 Trojan asteroids of Jupiter and 1 from the main belt.
And it's also interesting, we're going to do 3 Earth flybys, but what's really cool is not only flying by Earth, but that's from going after we've gone out to the outer part of our solar system and back, which is definitely a first.
And I don't know, I think Lucy may be engaged because from what I understand, there's approximately a 20-carat diamond on board the spacecraft.
Well, let's see, that's about right, because that's the same size diamond I gave my wife when I engaged to her years ago.
Well, I know that's a big commitment on Lucy because it's a 12-year mission, so.
Well, that's true, but the Lucy scientists definitely are committed to this mission, and that's a positive.
Absolutely.
But I tell you what, let's go out now to the pad and take a look at what's happening out there as rollout begins, and when we come back, we're going to get our first look into the science of the Lucy mission.
And joining us now is Tom Statler, who's the program scientist for Lucy. How you doing, Tom?
I'm doing great, Chris. Thanks for having me here.
How does Lucy fit into the overall NASA science mission?
Well, the NASA science mission is really to understand our Earth, understand our solar system, our sun, and our universe, which is, a small job. And part of that is really understanding where the planets came from. So asteroids are so exciting for all kinds of different reasons. They're time capsules into the past. They're basically leftover raw materials from the formation of the planets. And they're showing us what went into planets that we don't see now. They're also where they are in the solar system is telling us about how the planets arrange themselves and maybe rearrange themselves in the solar system. The asteroids that are close to the Earth are telling us clues about how the Earth might have acquired its water and its carbon-based compounds that might have set the stage for life. And also, the asteroids that are near the Earth, orbiting the sun, present a natural hazard to the Earth, and we're interested in doing that too. So asteroids are important to the NASA science goals for all kinds of reasons.
Now, we've studied asteroids in the past. We've been studying asteroids for a long time, but why Trojan asteroids?
Well, the Trojan asteroids are special. The important thing is that there's no such thing as just another asteroid, right? There are asteroids all through the solar system, and each one is telling us a story about a different aspect of the history of our planets. Everyone's heard of the main belt asteroids, and those are basically raw materials left over from the formation of Earth and Mars and Mercury and Venus. But the Trojan asteroids, those are the leftover raw materials from the formation of the giant planets, Jupiter, Saturn, Uranus, and Neptune. And we think some of those raw materials got swept into these Trojan groups early in the history of our solar system, and sending a spacecraft there gives us the ability to sample all of this different activity and all of this different history from the distant past.
Now we have 7 Trojan asteroids, but then 1 from the main belt. So why are we choosing 1 from the main belt?
Well, it's an opportunity, right? And we'd never pass up an opportunity for discovery and observation. So there is this one asteroid that the team named Donald Johanson after Donald Johanson, who discovered the Lucy fossil in Ethiopia. And it is actually an interesting asteroid. It's a very slow rotating asteroid. It may be a contact binary, 2 objects in contact with each other, but basically we're using it as a rehearsal. It's an opportunity to test out our processes, test the instruments, test our procedures, test the data pipeline, and make sure we have everything rehearsed to a T before we get to the Trojan swarms.
Now one of the cool things about the mission, and people may not know, we talk about the Trojan asteroids at Jupiter, but the Lucy spacecraft is not going to Jupiter.
No, it's not going to Jupiter. So the Trojan asteroids are associated with Jupiter, but they're not at all close to Jupiter at all. In fact, sitting here on Earth, we are going to get closer to Jupiter than Lucy ever will at any time during its flight. The Trojan asteroids are in the same path. If you imagine a racetrack around the sun, the Trojan asteroids, there's one group leading Jupiter ahead by 1/6 of a lap, and there's the other group trailing by 1/6 of a lap. So we're going in 2 totally different directions, not close to Jupiter, to study the Trojan asteroids.
Now, you've been working on this project since the inception as program scientist. Where do you see yourself 12 years from now at the end of this mission?
12 years from now, I will be an older young man than I am now. You know, one of the things wonderful about working at NASA is that you always find yourself doing something new. And I'm so thrilled by the fact that nothing that I'm doing today is something that I was doing 10 years ago. And maybe that's true too. And 12 years from now, I will probably be doing something different. But I really hope that I'm still associated with the Lucy mission, because it's going to be quite a ride.
Well, Tom, thank you so much for being here. Good luck with the mission. We have rollout today and launch on Saturday, but it's just beginning.
Yeah, absolutely. Thanks, Chris.
Hey, later in the show, we're going to be talking with Franklin Fitzgerald and Mick Woltman about the rollout of the Atlas V vehicle. But up next, we're going to learn more about the engineering aspects of the Lucy mission.
Joining us now is Mike Sakarik, who works with systems engineering with Lucy. I'm always fascinated by systems engineering because you're dealing with lots of moving parts, spacecraft, instrument, partners, etc. Tell us a little bit about the challenges of making all these parts come together for a successful launch.
Absolutely. First of all, we're happy to be here this morning. Really excited that you're sharing the Lucy mission with the world, because we're really excited about what we're going to be doing. We have a lot of different partners with a lot of specialties that they are bringing together, and the project system engineering role is to make all those different pieces work together between the project level at Goddard, Lockheed Martin, our spacecraft contractor, instruments that are coming from different institutions around the country, and other major components that are also manufactured by different companies. And we have to make sure from the project systems role that all those things are going to play together well when they actually come together to be assembled, and actually tested for the full spacecraft. But we have a really great team. We've had to encounter a lot of obstacles with COVID that we kept working together and drove right in through it to still maintain this first launch opportunity.
And so I was going to ask you about COVID, but obviously that's a big challenge. But clearly, you work through these issues, right? We're here today. Tell us a little bit about how proud you might be of that team.
I cannot say enough about how good this team has been, of all the different partners, what they've delivered. Starting after the first of the year, we've been working 7 days a week to make up for the schedule losses and impacts that we had due to COVID. And when it first hit, we had to do a lot of rearranging to make sure that we can get all the parts together on time, all the supply issues, the travel issues. But everyone was dedicated to making it happen. And a big shout out to our partners at Lockheed Martin for how they rearranged the Atlas schedule, which is assembly, launch, test operations. How they rearranged that to make sure we could still keep this first opportunity, because we only have 2 opportunities to launch. So we had to make it.
Impressive. Now, I tell you, that's complex in and of itself, but there's some complex things you're dealing with on Lucy. I understand you have some massive solar panels that are going to be powering the spacecraft. Can you tell us a little bit about how that came about? Because that's an impressive feat.
Yeah, absolutely. So because we're going all the way out, actually past the orbital distance of Jupiter, when we fly through these swarms, will be the furthest out solar power mission that's ever been. And to do that, we need these very large solar arrays. They're about 7.3 meters in diameter, ultraflex arrays. They were made by Northrop Grumman. And out at this distance, we're actually going to get 0.5 kilowatt of power to the spacecraft to do that. And these arrays are actually made out of, there's a fabric substrate that the cells are bonded onto that makes them extremely lightweight. These are, these are cutting edge technology to make something this big and this lightweight to generate power. But we had to do that to make sure we could get this exciting science, so far away from the sun.
Yeah, and powered by an impressive way. That's really cool. Hey, Mike, thanks so much for being on the show today.
Oh, happy to be here. I'm looking forward to lunch.
Awesome. When we come back, we're going to take a quick look at the pad, but when we come back, we're going to talk to Hannah Kaplan about the instruments on board. Hannah, you're an instrument scientist that works with Lucy. Tell us a little bit about your work with Lucy.
Yeah, so I've been working with the LRALPH team. So LRALPH is one of the main science instruments on the spacecraft. And we've been testing our instrument and preparing for this launch, and now we're excited to get back data from the Trojan asteroids.
Well, now tell me a little bit about that data, because what kind of data are you, from a science standpoint, actually looking to observe from these Trojan asteroids?
Yeah, so there are three main science instruments on board. One is LORI, which is basically a very fancy camera that can see very high spatial resolution images of the asteroid surface. There is a thermal emission spectrometer, which measures the temperature and the thermophysical properties of the surface. And then again, there's LRALPH, which is the instrument I've been most closely working with, which is a visible imager as well as an infrared spectrometer. And so we'll be getting back data from LRALPH that tells us about the composition of the surface, so what it's made of.
And so you'll get an idea visually of actually how it looks and the infrared, and how do you use both of them from a science standpoint?
Yeah, so we want to combine those images of what the surface looks like with what it's made of. And so we really don't know very much about the Trojan asteroids. They're dark, they're very far away. So we want to know if there are certain minerals on the surface, if there are ices on the surface, and those are the things we'll be able to see with the infrared spectrometer.
Now, Lucy has a very lengthy mission. I think it's 12 years. So you don't have to wait 12 years to get data. How is this data going to come back, and how can you use it?
Yeah, so we start getting data pretty soon after launch. Within the first year, we're returning back calibration data and trending data just to make sure the spectrometer is working as planned. And then with those Earth gravity assists that we'll be doing, we get some data looking at the Earth, which will be really fascinating, and then out to Donald Johanson. And so throughout that time, we'll be transmitting data back to Earth that we'll be checking out.
That's awesome. Now, where are you going to be for the launch?
I will be watching with the rest of the team, and I'm very excited. It's my first launch, so I'm really excited about it.
Awesome. Thanks so much for being on the show today.
Yeah, thank you so much for having me.
Franklin had a chance to talk to a graduate student about one instrument on board, the T2 cam, or sometimes referred to the TT cam. Let's check it out.
We're joined today by Amy Zhao, who is a grad student at Arizona State University. How you doing today, Amy?
I'm doing well. How are you?
I'm doing pretty good. Now, first of all, how did you get involved with NASA through your grad school at ASU?
So when I was first applying for grad schools, I knew working with space missions and working at NASA was something I really wanted to do. And when I first came to ASU, I started working with my advisor, Jim Bell, and he was working on a bunch of missions, so I got to immediately start working with this NASA mission.
So when you got involved with Lucy, did you work on anything else, or was it just the TT cam?
It was the TT cam immediately, actually, yeah.
Tell us exactly what is the TT cam?
So the TT cam is short for the terminal tracking camera, and they're used primarily as navigation cameras on the Lucy mission. When we come close to an asteroid that we want to observe, the TT cam system will detect this asteroid and center it in the frame so that the TT cam itself and all the other instruments on the satellite will be able to take measurements of that asteroid in the center of their observing frame. The primary function of the TT cams is for navigation, but a secondary function is to get science data from these images. Since during the tracking, TT cam will be taking images of the asteroid as we fly by, so those images could be used for things such as finding the topography of the asteroid, which is very interesting.
Now, the Trojan asteroids aren't the first asteroids that Lucy is going to encounter. Can you tell us about the type of warm-up mission before the Trojan asteroids?
Yeah, so the Trojan asteroids are very far out. It's going to take years to reach the Trojan asteroids. And before we reach one of the Trojans, we're going to actually fly by a main belt asteroid. And that main belt asteroid will kind of just serve as a test run to make sure our terminal tracking camera navigation function is working correctly, and also to make sure that the calibration that we have for the camera is working correctly.
Now, Amy, where are you going to be during the launch?
I will be in Florida at Cape Canaveral during the launch.
Awesome. Hopefully you'll be able to come by, or we'll be able to find you and see you in person, okay?
Yeah, I'd like that. I'm very excited for it.
Good luck on the mission.
Thank you.
Taking a live look at the VIF, or the Vehicle Integration Facility. And now we're going to go out to Franklin Fitzgerald and Mick Woltman, who's going to give us an update on the rollout and what it takes to get an Atlas V 401 from the VIF to the launch pad. Franklin, take it away.
Thank you, Chris. As you said, I'm here with Mick Woltman from LSP. Mick, can you give us an update on the rollout process?
Yeah, the teams this morning, LSP and United Launch Alliance, came on early this morning to do their processes, follow the procedure, finish up the preps they needed to do at the VIF. Some of those ran a little bit behind, and we are working with a small team, so people had to do certain tasks. So some of those tasks were delayed a little bit, which caused our delay to roll out at 10 o'clock this morning. But again, the team has this built into the procedure. As long as we get rolled out today to support a launch for tomorrow, we'll be good. So things are still looking positive for us, but the team is slightly behind on getting the vehicle out of the VIF and rolled to the pad.
Now, this rollout is actually almost 2 days in advance. Why is that?
Yeah, so because it's a planetary mission and because we are launching at 5:34 a.m. in the morning, the teams have to get on console at midnight the previous day. So we work into the schedule what we call a crew sync day, where the team can have a down day. They've been working very hard to get this vehicle ready over the last couple weeks. So it's a down day to get them prepared so they can come on station at midnight to do a launch at 5:34 a.m. So in order to do that, we need to roll to the pad the previous day, which is today, October 14th. And as long as the team gets that done today, we can have that crew sync day and get ready for launch early in the morning.
Sounds great. As I look at the VIF, I can see the Atlas V in there. Coming from LSP, how do you select the Atlas V 401 configuration for this mission?
Yeah, so Lucy, as you guys have heard, you guys have been talking about a historic mission heading to the asteroid, Trojan asteroids. So Goddard and Southwest Research Center, who have Lucy spacecraft, came to us with some requirements. And within Launch Services Program, we take those requirements and then we go out and look at the catalog of commercial launch vehicles that we have. And we selected the Atlas 401, which is the most common configuration flown by United Launch Alliance for this mission. It had met all the performance requirements, all the environmental requirements to get Lucy on its way for this 12-year mission. So that's part of the job with the guys at LSP, the ladies at LSP, that do that analysis and make sure things are going well.
Yes, as we continue to wait for the rollout to begin, the Atlas V is on a mobile launch platform. How far does it have to travel, and at what speed will it travel?
Yeah, so that's a unique design that United Launch Alliance has. It's a clean pad concept using a mobile launch platform to move the rocket out to the pad. And what they will do is put some trolleys or train car type units under there to lift the mobile launch platform up. It'll travel about 1,800 feet to the pad, traveling at about roughly a half a mile an hour, Franklin. So it'll take about 30 minutes for them to get to the pad. Once they get to the pad, they will lower the mobile launch platform down onto the stanchions at the pad. And then the team will begin the task the rest of the day of hooking up all the commodity autocouplers, all the electrical power, all the environmental control systems to get ready for launch on Saturday.
For those who are watching the program right now, you can actually see there are 4 structures around the launch pad. What are those used for, Mick?
Yeah, so those actually help protect the launch pad here at Complex 41. They are called catenary towers, and attached to each one of those catenary towers are some wires that form a square around the pad. The rocket actually, when it lifts off up between that square that's in those catenary towers. And that's there to protect the pad and the rocket during lightning or weather events that would harm the rocket. And that way we can then look at what happened and if we got to retest or do anything or if we can go. So they're there for the protection of the pad and the rocket.
Now, would there be any weather conditions that would prevent rollout?
Not right now. The only big thing, I say that not right now because today here in Florida looks very nice day. As we said, there's some process stuff going on that's delayed it, but typically there would be a wind and weather constraint that is required. United Launch Alliance has requirements to make sure that when you roll the vehicle out of the pad on that MLP, that the wind is at a certain level so that you don't disrupt the rocket while it's on the MLP. Because again, stacked on the MLP, it is held down by the hold down bolts and the ground wind damper arm that's on the second stage, and that's all that's holding the rocket on the MLP. So you want to make sure your wind is below a certain level as you're transporting out to the pad before you get it secured.
Speaking of weather, what does the forecast look like for Saturday morning?
Oh, I'm really excited about Saturday morning. It's a clear day, 90% chance of liftoff, only a 10% chance of violation, and that's only due to cumulus clouds. Launch weather officer from the Space Force Delta 45, Jessica Williams, told us yesterday that the cumulus clouds is a very low risk, but to make sure we cover that, there is that 10%. But she told us that Saturday's weather looks amazing for liftoff at 5:34.
Sounds great. Mick, where are you going to be Saturday morning?
I will be actually at the ASOC doing the PAO launch commentary, Franklin, with you guys, and looking forward to this liftoff and sharing the historic moment of the Lucy mission and everything that's going on. I'm excited about this, be able to see it from the ASOC, which is just a few miles from here.
Sounds great, Mick. Appreciate you being on the show as usual, and we'll see you in a couple days.
I appreciate it, Franklin. Thank you.
Hey, guys, back to you in the studio.
Well, despite having a delay during our live coverage of the Lucy rollout, I'm happy to say that rollout did happen, and it was quite spectacular.
Not only was the rollout impressive, but the launch was impressive too, especially at 5:34 in the morning.
Yeah, it's not very often you get both in one ending of a show, right?
That's right.
I'll tell you what, make sure you go to our YouTube page and subscribe so you can be informed about all the programs that we're bringing to you. And we also want to remind you that you can visit our Facebook page or the NASA website. Any way you want, follow us. We'll keep bringing you live shows, live launches, and more content from NASA. You're watching NASA Edge.
An inside and outside look at all things NASA.
Lucy's in the sky with diamonds. Yeah,
Big diamond.
that's right.